Now, some other issues we have to take into consideration are risk. The more risk that's involved, the higher rate that we might demand on the project. Inflation. We have inflation. So the dollars we receive down the line may be inflated by whatever the inflation rate was during that period of time. Now, right now our inflation rate is very low. It's something about 2%. But certainly in my lifetime, I've seen inflation run as high as 10%. And then we need to take into consideration income taxes. So in other words, those returns don't all flow back to us. We have to pay taxes out of that earnings, and so we have to take into consideration income taxes. So basically, in this course, we're going to ignore the concept of inflation and income taxes, but I want to bring those out because those are concerns and implications you will see when somebody is analyzing a capital investment. Now let us take the reverse and look at a situation where we're paying money out. When we're receiving money, we want to get it back as fast as we possibly can. But when we're paying money out, we want to pay it out as slowly as we possibly can. So let's take, for example, we're going to buy an automobile. And this automobile is going to cost us $20,000. Now, we may have the cash of $20,000 to lay down and buy the automobile, or we may not have the $20,000. But either way, this analysis will work. Now, we have two different leases that are available to us. Now, these are leases where at the end of the 5 years, you will own the automobile. This is not an operating lease. This is a capital lease. So in all three instances where you buy the car, or you go with lease number 1 or lease number 2, you will own the title at the end of the 5-year period. So under lease number 1, we pay $1,000 out when the car rolls across the curb. Then we pay $4,000, $4,000, $4,000, $4,000, and year 5 we pay $10,000. Now I've used a discount rate here of 10%. So if you go to the present value of $1 table, under 10%, you will see that in year 1, I would use a rate of 0.909. In year 2, 0.826. Year 3, 0.751, and so forth. Then I multiply that rate times the amount of cash I'm paying out each year. So on a discounted basis over 5 years, the present value of that cash flow out is $19,886, which is less than the present value of $20,000. So I'd be better off going with this lease because I have these money over the years to invest, and I would be able to pay them out over 5 years rather than laying down the $20,000 in the year 0. Now we have another proposal where we pay a flat amount of $5,000 each year for 5 years, or $25,000. Now, in this case, under lease number 2, we can use a different table where you have the same amount being paid out each year or being earned each year. You can use the present value of the annuity table, and that's what we're doing here. So we take $5,000 times 10%, go down to year 5 on the present value of the annuity table, and we get 3.791, or the actual discounted present value of the outflow is $18,955. So in this particular case, we should take lease number 2. Now you're probably going to say, what's the significance of the 3.791 on the present value of the annuity table? And I'll tell you how that's arrived at. if you go to the present value of $1 table and you add up the rates for every single year, for example, here, if you add up 1, 0.90, 0.82, 0.71, 0.683, 0.62. So if you take the 0.90 through the 0.62, you'll come up with 3.791. So it's just a faster way of calculating the discount if you have the even dollar amount each year. So again, try it. Add up 0.909 through 0.621 and you'll get 3.791. So it's just a faster way of calculating it. People really don't like debt, and they say, well, why should I not pay cash for my car if I have the cash? Well, because you're passing up opportunities to invest that money to earn a return. For several years, I was the chief financial officer of a very large trucking operation. We had 600 power units, big 10-wheelers, and we had about 1,500 pieces of trailing equipment. We rotated our power units on a 3-year cycle. So every 3 years, we replaced the fleet. So 1/3 of the fleet was replaced each year. These units cost at that time in the neighborhood of about $80,000. And so we're replacing 200 units every year. So we were spending about $16 million on capital acquisitions every single year. We had excellent credit. Obviously, we couldn't finance $16 million of equipment purchases, so we had to go finance them. So we would go out for proposals, and we get them from U.S. Leasing and from Bank of America and U.S. Bank and all different kinds of financing organizations. And all of these proposals were different, okay? They'd be something like, okay, this is our interest rate, no payments for the first year, maybe no payments for 2 years, maybe there would be staggered payments of different amounts each year, and they're all different. So we had to make an evaluation as to which of these proposals we were going to take. We didn't care about the interest rate, and you should not be concerned about the interest rate. You should be concerned about how much money you have to pay out and when you have to pay it out. So we'd lay these all out, and we would look at them, and of course they always wanted to sweeten the deal. This doesn't sound good, harking back to our ethics lecture, but they'd want to take you to Spyglass to play golf, or they would want to take you on a fishing trip to Alaska and so forth. And yeah, go ahead and take the trip, just so long as you didn't lose your objectivity. So we'd come back and lay these out and calculate the present value of those outflows, just like we're doing here. And the one with the lowest net present value outflow is the proposal we went with every time. My, oh my, did that ever make some of these guys angry? Because many of these people were paid on commission, and they didn't want to lose the $16 million sale, so to speak, or investment of money for their companies. But it does work. Try it. You will like it. You'll like it. Remember, it's all about the time value of money. Now let's talk about the internal rate of return. Internal rate of return also uses discount rates, and it does recognize the time value of money. But the internal rate of return calculation finds the return that causes the net present value to be zero. So in other words, we take our inflows and outflows, and by looking at the discounted cash flows, we find a rate that comes to a true zero. So we're not prescribing a rate, we're calculating a rate. So the first, how we calculate it is we take the present value of the annuity, which is the PVIFA times the annuity or cash flow. So the PVIFA is calculated as taking the present value of the annuity divided by the annual cash flow. And then you want to use the present value of $1 annuity table to arrive at the internal rate of return. So here we are looking at the present value of the $1 annuity table. Now, you can look at a table or you can make this calculation on a financial calculator. So, let's assume that the original investment was $20,000 and the annual cash inflow is going to be $5,800 per year. So first we calculate the PVIFA by dividing the 20,000 by 5,800, or you get 3.448. So then you go to the present value of the ordinary annuity table and you look across to find in year 5 what discount rate is approximately 3.448. And if you look at the table, you'll find that it's slightly less than 14%. Now, if you were to use the financial calculator to find the actual internal rate of return, you'd find that the actual internal rate of return is 13.82%. So then you have to say, all right, does this meet my cutoff rate? If your cutoff rate is 15%, it doesn't meet it, so you reject the opportunity. If your cutoff rate is 13%, then you accept the proposal. So this is just another way to arrive at using the net present value and the time value of money to evaluate the project. And you actually find both the discounted cash flow and the IRR both being used to look at projects. Some people maybe use both of them, some maybe use one or the other. Now, the next thing we're concerned about is what we call CapEx. This refers to, are we making enough new investment to cover the depreciation on the present assets? And you need to do this to grow and keep up with the progress. So you have CapEx to depreciation and CapEx to sales. So where you have CapEx to depreciation is the company investing enough money to keep up with depreciation. So what you would do is you would take new investment, divide it by depreciation times 100%, and that is your CapEx rate. In the case of CapEx to sales, you say how many sales dollars are going into new investment. So then you take the new investment divided by sales times 100%, and that tells you how much of the sales dollars are being used to look at the new investment. These can be used in combination, for example, with evaluating a manager. Think back to our discussion on performance measurement, where we said a manager may not be making enough new capital investment because he or she does not want to increase that particular metric in measuring their return. So top management might evaluate part of the performance by looking at CapEx, which would immediately tell them the manager is not making enough new investment, and therefore they might be penalized for taking this type of action, which is detrimental to the company in the long run. So let's assume we have depreciation of $500,000 and a new investment of $600,000 and annual sales of $10 million. So you calculate CapEx to depreciation by dividing the new investment of $600,000 by $500,000. So this says we're investing $1.20 in new property, plant, and equipment for every dollar we're depreciating. So they're advancing, they're looking forward. Now CapEx to sales, we divide 600,000 by 10 million and we get 6%. So we're saying that 10% of our sales dollars are being reinvested in new property, plant, and equipment each and every year. And you probably would compare this to your competition. You know what they're investing by looking at their statement of cash flows. You know what their depreciation is by looking at their income statement. So you should probably be keeping pace with your competitors in at least what their CapEx is to depreciation and sales each year to keep in a competitive position.